So we're looking at latent heat. So that's a new concept for you guys as of now. Till now, I have not yet introduced or spoken of something called as latent heat. So what is this about? When you supply heat to a substance, two things can happen. Either temperature may increase or substance may undergo a phase change. Do you guys agree? This aspect we have kind of discussed. And we ignored the phase change. Now we are not. We ignored the phase change. In this section, we are not. This section has to do with the phase change and everything actually. We'll combine everything. So latent heat deals only with the second case, that is the phase change without temperature change. So once we deal with latent heat, then we move on to the next concept wherein we combine all of this and see the entire picture. Okay, the key idea is not all supplied heat rises temperature. So basically not all the energy that you supply will increase the temperature. Rather, a large amount of heat is needed to change the phase of a substance at its melting or boiling point. It's so for all the materials. During this entire phase change, temperature remains perfectly constant. So that's the unique aspect about this. Okay, that's the unique part. So during phase change, temperature remains constant. Yes, completely constant. For example, I said 0 degrees Celsius remains exactly at 0 degrees Celsius until every bit melts into water at 0 degrees Celsius. Same thing with boiling. So heat keeps flowing in, but the thermometer reading will remain the same. Where does the energy go then? The supplied energy is used to overcome or weaken the intermolecular forces. The increases the potential energy of the molecule, rearrange the molecular structure. So basically breaking things up. It does not increase the kinetic energy though, hence no temperature change. So of course energy has to be used somewhere, right? Energy has to be used somewhere, and that somewhere is to do with all of this. Breaking of intermolecular forces. That's the most simplest thing that you can think of. Now, molecular expansion. When you're moving from solid to liquid, that is fusion or melting. So what we're looking at is molecules in solid vibrates about fixed position in a rigid lattice. At melting point, added energy breaks these rigid bodies. Molecules gain freedom to move over each other and thus becoming liquid state. So heat is stored as an increased potential energy. So we are trying to explain. So what happens? We are trying to explain this part. So what happens to the energy? We started off with solid to liquid. So we are talking about molecules gaining freedom to move over each other, right? So this is nothing but we are increasing the potential energy. You flip the scenario, this is how a liquid becomes solid, freezing, right? So if you flip the scenario, it becomes freezing. So liquid to gas, that is your vaporization. So molecules in liquid are close but still attract strongly, right? To become gas, molecule must completely separated against attractive force. So the huge increase in intermolecular distance, so very large increase in potential energy. So in each of this case, what is happening? The potential energy is increasing. So obviously to increase potential energy, if you want to lift an object, you have to put that effort, right? So that's all of this is about that. So we are pushing the molecules apart. This is why latent heat of vaporization is much higher. Okay, guys. So all of these terms are a bit new, but yeah, concept, if you think about it, it's not that old. I mean, it's not that new. So this is the first part of your latent heat. So not all the energy supplied in the form of heat is used up in increasing temperature. It is also used up in breaking of bonds and increasing the potential difference and so on and so forth. If you flip the scenario, if you're moving from gas to liquid, there's a lot of potential energy that is lost, and that is redistributed as heat and stuff. Right? That's released as heat. The energy is given up as heat. And so you can flip the scenario around and you will understand the other process. Okay. So you can have a look. So there are a few more things in part 2. We'll wind up latent heat in part 2 actually. For now, I think this is good enough. So we are going to take up, sorry, I'll just add one more thing. We are going to take up water as an example to talk about all of this again as a whole actually. So we are going to do that.